Show how electron withdrawing substituents are meta-directing in electrophilic aromatic substitution reactions. So if we have a benzene ring with an electron withdrawing substituent such as CF3, trifluoromethane, if we react this with this electrophile, NO2+, nitronium, which is made when you react nitric acid with sulfuric acid, the NO2 will add at the meta position. 1, 2, 3. You have the electron withdrawing substituent, and the NO2 will add at the meta position. Now, let's see why addition at the substitution at the meta position is favorable. All right, so this is trifluoromethyl benzene CF3 plus N double bond O, 2 lone pairs on each oxygen, and you have a plus charge on your nitrogen. Alright, so we are doing meta substitution. We have an H there, yes, and yeah, we have an H there and an H there. Alright, so when that pi bond attacks that nitrogen and you form a covalent bond between that carbon and that nitrogen, this is what you get. 1, 2, you have that H there, and you have that H there, and now at the meta position, you're adding the NO2, yes, and O. So plus charge on nitrogen. When that attacks the nitrogen, that bond there is going to have to go to oxygen as a third lone pair. Alright, so we have a plus charge at that nitrogen, and yeah, now we have a plus charge. Yeah, that double bond goes away, so we have a plus charge at that carbon. So that bond there is going to help out, and you form this resonance form H, and O2. Of course, you have a plus charge on that nitrogen there. We have a CF3 there. Alright, so when this bond helps stabilize that plus charge, the plus charge then moves to that carbon. Yes, so from that carbon, it moves to that carbon on the left side. Another resonance form is this. So this bond is going to help out. It's going to move from there to between that carbon and that carbon, and you form this. You have a CF3 there, H, and O2. Alright, since this is moving from here to there, the plus charge goes there. So you have a 1, 2, 3, you have a third resonance form. Alright, next. Yeah, see, it moved from that carbon to that carbon to that carbon. Notice that the plus charge bypassed the carbon that bears the electron withdrawing substituent. If that carbon were to go at that carbon, then you would have had a very, very unstable species, because this is very electron deficient, and then you add a plus charge there. Electron deficient, plus charge, very, 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 very unstable. So therefore, if we nitrate at the meta position, that carbon there is bypassed by the positive charge, which is favorable. That is why whenever we have an electron withdrawing substituent, most of the time the the electrophile adds at the meta position. Meta.